Alrighty, so we are live. Hey, so does everyone want to introduce themselves? How about you start off, Mike?
Okay. Mike Pearson. I've been a developer for 10 years, and AngularJS first, Angular after that, and I've done a little bit of React over the last year. And yeah, I'm in Angular GDE as of like a month ago or 2 months, something like that. And I've been like doing a YouTube channel and exploring new technologies like Solid.js and Qwik. And I'm a huge fan of RxJS, so try to figure out how to get RxJS inside Qwik. And it's been really fun. But yeah, that's me.
Cool. And I'm Rob, or you can call me Rusty Rob because I've been learning a bit of Rust lately. But I guess I'm a bit of like a polyglot. I try to dive in and know a bit about everything, but try to go deep on some things as well. So I've been doing all kinds of development, especially Angular, ever since Angular came out. And yeah, I've had to optimize the performance of like a digital publication, which was an Angular app, and it was like a single page app once, and it was like taking 2 seconds to load. And so I've got a few scars from that. There was like a 3-month contract, but it was really interesting trying to make it instant, but it was still kind of flickering when it hydrated and stuff. So I saw Qwik and I was like really interested because I was like, man, like if only you'd built that 5 years ago, that would have been awesome. Like solved it so much better and quicker. And I'm also from the developer's perspective, I'm really keen to talk today about Qwik and like the developer experience. How can I use it? What can I use it for? And also I'm building a framework for factories where you have all your sensors within a factory, maybe hundreds of thousands of sensors, and they're kind of like event listeners. And so I'm kind of using my Angular knowledge to kind of think, how can I build this framework? Build a snowball of data with like a reactivity graph across factories and stuff like that. And just kind of like thinking about maybe code generation with TypeScript and just how to represent things in data models and stuff. So just kind of all different reasons for wanting to talk to you today. So happy to meet you. And do you want to introduce yourself a bit?
Yes.
I'm sure you need
Hi.
no introduction,
Hi.
but
Hi, I'm Miško. I'm CTO of Builder.io. Builder.io is a headless visual CMS system. CMS means content management, which means marketing people can design whatever they want. Headless means it's running on your infrastructure. It's not like something hosted somewhere else. And visual, it means it's drag and drop. And we care about performance. And so we're working on this project called Qwik. Qwik is a new kind of framework. And yes, I had something to do with AngularJS and Angular. And so now I moved on, and I want to make the web faster, and that's my thing.
Awesome. And did your journey with Angular help influence this? And
yes,
how did you meet the team that you have now at Qwik?
Yeah, absolutely. The previous journey definitely influences what you do on next step. So I think maybe the journey starts in like 2019. I was in NGConf. I was doing a keynote, and I was talking about like how to make Angular run faster. And I basically in that talk I laid out what eventually became Qwik. I even termed the term resumability. So I was at Google for a pretty long time, about 16 years. And after 16 years, I was just like, well, I'm either going to be institutionalized over here or I'm going to try something new. And so I left not because I was, unhappy or anything like that. I just was like, okay, 16 years is a long time. Like I need to try life outside of Google, see how it is. And so I started exploring, and I actually did not want to build another framework. That was not a thing that I wanted to do. And I looked in all kind of places, and I came across Builder.io. And Steve was telling me about this problem he has of like how difficult it is to get websites to start up fast, and how important it is in e-commerce space to do this because it's money. And I said, I actually know a thing or two about this. And so I kind of built a prototype of Qwik, and together we kind of tried it out. And he was just blown away that all of a sudden his website, he was trying to get fast since forever. With Qwik, it was just like out of the box, fast, no problem. And uh, that's kind of how it started. So I kind of joined Builder, and the focus we have now is on making the web fast. And making the web fast really comes down to a very simple thing, which is ship less JavaScript. If you can figure out how to do that, you're good. Actually, let me rephrase that. It's not necessarily ship less JavaScript, although shipping less certainly helps. It's execute less JavaScript, right?
I was going to say,
how can you figure out how not to run stuff?
Yeah, I guess you could put a lot of the JavaScript into the CSS and HTML, make those bigger. That would be like a cheat way. But
yeah. So the key is not to execute it, right? The key is how do I not run JavaScript? And so for that, we have like two projects. One is Qwik, which is basically your first-party code, and it's yet another framework. But it's a very unique spin on how frameworks actually work, and I think that's what's kind of unique about it. And we can talk about it. I'm sure we're going to talk about that, right? And we also have this other thing called Partytown, and Partytown is a way of taking third-party code and running it inside of web workers so that, again, performance, right? So that the main thread is free to focus on user interactions rather than focusing on running all the third-party code.
Awesome. And when you're kind of exploring and planning things out at the start, were you using like pen and paper or Excalibur or just coding it? Or
no, I've always just
framework?
kind of code things up. I always, it's like you can draw for a little bit, but like you're done drawing in like 5-10 minutes. After that, you gotta try it, and it's only when you try it do you realize all the ways in which it doesn't work, and then you go back and be like, okay, so how can I solve these things? How can I work around it, etc. A lot of it is discovering where your mental models break down. And then saying, okay, which constraint can I relax or move or do something with it so that I can, get past this problem.
And do you use like TypeScript in the compiler to help you with that kind of stuff? Or do you kind of start with dynamic language and then
make it more TypeScript all the way. TypeScript is all the way. I'm addicted to it. Like it's I can't imagine writing code without it.
Yeah, I tried Dart once when it first came out, and then we switched over to TypeScript and Angular. But
it's just a way better fit for the web.
Yeah. And actually, a long time ago, when I first saw AutoML came out with Google, I was like, man, I want to make like Auto UI. So I bought the domain name. But then I never actually did anything with it because I was too scared. But like, it seemed pretty hard. But what is Builder like? How long has that been around? And like, what's like the business model? Like, why are you like? Is Qwik to kind of help your business model, or is it like it's like an open source thing? Yeah.
No, it totally is tied to the business model. So Builder has been around for about 5 years, and as I said, it's a headless visual CMS system. So there are a lot of CMS systems out there. Like imagine Wix, right? You can come, open it, and drag and drop and build stuff. But Wix doesn't, it's great for mom and pops kind of shops, right? But it doesn't really scale to like if you're Target or Macy's or somebody, right? Because you don't want to host on somebody else's infrastructure. You want to host on your infrastructure. And the reason you want your own infrastructure because, well, you want to hook in all kinds of analytics, A/B testing, but also you want to push things into the UI such as, current latest sales and what are the status of your stock, whether something is in or not, shopping cart, etc. So hosting on somebody else's platform is just not a thing, and this is why you have this whole headless space. But if you want to have a drag and drop editor, it turns out you kind of have to own the stack, and this is why visual editors are not really available in the headless space. So the innovation that Builder brings is basically we figured out how to put a visual editor on a headless thing. And the way you do that is you basically install it through an npm install. But the trick is that you need to have a different editor or different SDK for different things. So you need one for React, one for Angular, one for Vue, one for Svelte, and so on and so forth. And you can see how, well, that's a huge undertaking. And this is the reason why most people don't go that particular route, and instead they go the headless non-visual route because they just give you a bunch of data and they say it's your problem. How do you want to display it? So in order to do this, we have this other project called Mitosis, and Mitosis allows you to write code once, and then it spits it out for whatever framework that you want. And that's basically how we can have these editors for basically every single framework that is out there.
Well, how many people working on that?
So we have one person working on the Mitosis and the SDK, and we have 3 people working on Qwik, Qwik, etc. And so the idea, so 4 people total, basically working on open source. But this open source work is directly tied to the success of the company, right? Part of the thing is, we want to have a headless visual CMS, but also, our customers come to us and they're like, well, I want to have a landing page, but I want the landing page is super important to be super fast, right? And so if they come in and they say, oh, great, I can use your editor and I can build it on my existing stack, which happens to be, let's say, React. Well, yes, but it doesn't perform very well. And that kind of affects my conversion rates, etc. So like, how can I have this landing page on a stack that performs well? And because we can generate output for any technology out there, we kind of knew that it doesn't matter which technology you choose, whether you choose Angular, React, Vue, Svelte. They all claim that they're fastest, but in reality they perform about the same. There are differences. I mean, they're not totally the same. There are differences, but for the most part, it's about the same. And the reason why it's about the same is because they all do hydration, right? And so, yes, maybe some are more optimized than others, but at the end of the day, they all do hydration, and that's really the reason why they're slow, right? So if you can figure out a way to get rid of hydration, then, well, your application becomes fast, right? And so that's the trick of Qwik. Qwik is basically a rethink of how frameworks work. And so, Builder kind of knows this because we generate the same site in different technologies, and we kind of look at the performance at Google PageSpeed scores, and we know that they're all about the same. And because they're all about the same, it's kind of hard to kind of win this battle, right? And so Qwik was designed so that it will give you 100 out of 100 kind of out of the box. And the only way to do that, the only way to get 100 out of 100 is don't execute JavaScript on the client, right, as part of hydration. But that's kind of a hard constraint if you want to also have interactive websites. So how do you do this, right? And this is kind of where the magic of resumability comes in, because it basically allows you to start your application with 0 JavaScript, and then as the user interacts, you kind of stream just the necessary amount of JavaScript for it. Of course, there's prefetching, so you never wait for the network latency. But that's kind of the trick. And so then you kind of see, hey, one technology is different from all the other ones. And not because we optimized it more or we worked harder, etc. It's because we fundamentally approach the problem from a different point of view, right? If you kind of chat with, follow the Twitter, people are like, yeah, hydration is good enough or whatever. They have all these arguments. But it's not good enough because real world data will tell you that like there's a difference, and if you can be just a few milliseconds faster on startup, it can translate to huge amounts of money for you. I believe there's a famous quote where Amazon said, well, we tried React and no way we can use React because like it's just not fast enough, and the startup performance would be so much worse that we would lose millions. And so yeah, we don't like writing our site kind of basically handcrafting it, but we have no choice. And so I want to change that, right? I want to have a world where you can build a site with modern tools, modern design practices and DX, but also have this amazing performance where you start with 0 JavaScript.
Yeah. So I saw a tweet today from Shai Resnick that you retweeted that describes how Qwik works in a way I hadn't seen before. Something about breaking the code into like packets and then allowing it to buffer on the client side. Could you describe like basically what is your favorite way of describing what I've heard a lot of
yeah, there's a lot of different ways to talk about it. It kind of depends. If I describe it, the problem is there's a lot of moving parts to this. Like it's a complete rethink, right? So like the way people normally work is they say like, well, I know how X works. So if you just explain to me the delta, then I know how Y works. right? I mean, that's kind of just how humans are kind of set up. The problem is the delta here is large, and so you have to be like, well, maybe I'll just tell you a part of it because I don't want to explain the whole thing all at once, like it's too much. And the problem is the moment you explain only a part of it, then they automatically assume that the other parts are broken. So you're like, oh, it's lazy loading. Oh, that means it's slow when you click it the first time because the network will cause a delay. It's like, no, that doesn't mean that. I haven't explained that part. So so kind of this is the kind of the angle. Anyways, the tweet that Serializing had basically has this idea that, you know, the way existing apps work is that you kind of download all the code up front, and then you have to execute it because of hydration. And that's it. Once the code downloads and executes, the application is fast, right? But the thing we want to solve is that initial getting it up and running. And so what Qwik does, part of it, is that is really good at breaking up your code base. And you say, well, but my framework already knows how to lazy load code. So like, how is this different, right? And so it's a question of granularity. And also, granularity is one dimension, but there's also this thing where like, resumability doesn't have to run the code that you would normally have to run. And so there's this other angle of like, because we don't have to run it, we don't have to download it, right? And so the idea that Serializing is pushing forward is that, hey, we take your app and we break it up into little tiny chunks, and then as you interact with the app, you know, we're only executing the next chunk that you need for the app. And because if you think about it, let's say you have a page that has 1,000 buttons, right? Each of these buttons has different behavior, right? So it's not like a same button 1,000 times. It's a different things, you know, like log in, go to settings, buy button, log out, you know, send a comment or whatever. The point to understand is there's code behind each of these buttons, but it's not like you can interact with all the buttons all at once, right? And so it makes sense to put all of this behavior of these different buttons into different chunks and then start streaming them in a kind of a statistical way of like, well, I think you're more likely to click on this thing. So I'm going to make sure that this code is available here first. And then if I have nothing else to do, I'll download the other buttons in kind of the statistical probability as well. And that's something that's fundamentally is not available to other frameworks because, well, sure, other frameworks can do lazy loading, but there's this caveat which nobody talks about, right? And this caveat is you can only lazy load components, so the granularity is different, right? You can only lazy load components, and you can only lazy load a component if it's not currently in a render tree, right? So if it's not visible, then you can lazy load it, right? The thing is, if the component is visible, sure, you can lazy load it, but that isn't going to help you because as soon as hydration runs, you will traverse that lazy loading boundary and you will get the component one way or the other. And so the trick is really how not to execute hydration, right? How to run it. And that kind of gets us to the next problem, which is like, well, a lot of people define say like, oh, Qwik just does hydration in a different name or whatever. And the point over there here is that hydration fundamentally requires execution of code, right? And you can argue like, oh, I'm doing delayed hydration, and I'm prioritizing hydration, or I'm having islands, right? So that now you're kind of arguing about which code runs when, right? But resumability fundamentally doesn't run code. And I know it's a kind of a hard thing to kind of wrap your head around, and I'm sure we'll kind of run into it. I mean, we'll discuss it later on. But because we fundamentally don't run code, we don't have to execute it, right? And because if you don't have to execute it, we don't have to download it.
And so when you click on a button, it's like an on-click event listener or something. So it knows the chunk to grab. That's already probably grabbed it already from the service workers. Is that right? But then,
yeah,
does that chunk have multiple things in it? So is it kind of runs something from within that chunk, or?
Yeah. So these are all optimization. So maybe we should talk about like how it works first, and then we can talk about the optimization strategies by which we make sure that there is never a delay, right? And by delay, like again, like a lot of people oftentimes like, oh, they think they know how what Qwik is, and therefore they're like, oh, so that means that every time I click, I will have to wait for a network round trip, which means if I'm in a tunnel, my app stops working. And that's not what's happening underneath at all. And so I think it's useful to kind of separate a concept that it's a concept that doesn't really exist in other frameworks. And that is the distinction between downloading code and executing the code, right? Because in other frameworks, hydration happens, which causes you to execute the code. The download and execution are kind of coupled, so you don't really think of them as two separate things, right? But in Qwik world, we eagerly download code so that we make sure that you don't have when you can interact with things, but we don't execute the code, which means we don't even load the code into the V8, right? We prefetch it and we put it in a cache, but it's not in the V8. And so even if you go to the tunnel and you click that button, it's not a problem because the cache is going to get a cache hit and you're not going to pay any penalty for it. So the other question you kind of had was like, well, how does it all work, right? And I think imagine a simple world where you have my app component, which is the root component. And then my app has a single child component, which is, let's say, a counter, right? And a counter has a state. So it says, my current count is, I don't know, 1, 2, 3. And it has a binding that shows what the current value of the count is. And it also has a button that you can click and it increments the count, right? Now, when you make an application like this, typically what happens is you have to have an entry point. And again, it's a thing we don't normally think about. But if you think about it, the root component is the entry point because it's the thing that, somewhere in your application, there is a code base, there is a piece of code that basically says hydrate this root component, right? And so that's where the execution starts. And so now as you're hydrating, you go to my app and you execute my app, and my app returns, the HTML associated with it. And inside of that structural HTML, you're going to have a child component called the counter. And so then the framework goes and executes the counter. And again, the counter runs and it returns the HTML. And inside of that HTML somewhere, you're going to have the state, which is what the current value is. You're going to have information about the fact that it's bound to this output. And you're going to have a button, right, that has a listener. And it has a closure that, this is the code that you run, right? And so now if you think about it, what just happened is you essentially just executed the whole app, right? You executed the root component, you executed the counter, and you were forced to eagerly create the closure for that button, which means the closure had to parse and all this stuff had to happen. And the closure has to parse because the VM, right, the V8, needs to know that the closure is closing over some variables, and the variable it's closing over is the state, right? It needs to know that like, oh, you're closing over the state, so that when you click it, you can go and increment the state, okay? And as a result, because there's only one entry point, right? There's only one thing that you can import. You don't have choices. Like if that's the bundle you deliver to the browser, like what else are you gonna do? Like you have to start in the exported symbol, which is the thing that does hydration. And then you go to my component and the counter and the listener and all that stuff. And that's how you bring it up. And so in order to make the HTML interactive, you have to fully execute the app. And during the execution, the side effect of the execution is that you restore the state. So you now know that the value of the counter is 1, 2, 3. And you also attach the listener to the DOM, right? And now that all this thing happens, it's only then that the user can go and click on the component.
Yeah.
Okay,
and so you're going to do the alternative. So
that's how the world works
Angular
today.
and React and stuff do. They kind of
everybody works
render
this way,
your
right?
component.
Everybody works this way.
And so now you're going to say how Qwik does it, right? And
yes,
I'm also keen to know how it affects like debugging or code navigation. Like, so the way you write your code stays the same and it's structured the same. Is that right? But then maybe the way you debug or maybe the parent-child interaction will be slightly different. So yeah, go ahead. But I'm keen to know those things. Yeah.
So let's talk about the other side, right? Let's talk about how resumability is kind of different. So let me show you first how it works, and then we can talk about how we get there in terms of DX, right?
Yeah.
So imagine you kind of create a different kind of bundle, and the bundle you create is that each component is exported. And not only each component is exported, but each listener is a top-level export. And we're going to talk about later how we get there so we don't actually have to do this, because that's a lot of work and nobody would want to write it that way. But imagine you have a bundle where everything is exported. So now when you want to wake up the application, instead of going on the root entry point and then recursively kind of getting the whole thing, you can really enter anywhere, right? Depending on the situation. So in our case, when the application is rendered on the server, we already know that all the HTML is present. Therefore, the only way we can enter the application is really through the click, right? If you don't click, there's nothing to do because, well, the page is already rendered, right? So really the only way you can enter the application is through the click. And if you think about it and if you generalize it, the only way to enter any application on a web is through an event. Some form of event gets the thing going, whether it's a obvious thing like mouse move, click, or scroll, whatever, or it's an implicit event like on document load or on idle or on visible or something like that, right? It's some event that kind of kickstarts the process. And so if the user doesn't interact with the app, there's really nothing to do. We've already correctly showed everything to the user. So now the user comes in and wants to click on the app. And so now you have the first problem, which is like, well, how do you even know that this button is clickable? So what you can do is you can set up a global listener, right? There's a piece of code that we call the Qwik loader, super tiny, about 1 kilobyte, executes in like 10 milliseconds on a mobile device. Really nothing to talk about, right? Super, super tiny. And so we eagerly execute this code. And what this code does is it sets up a global listener for the click events. And that's it. It just waits. Now the user comes in and clicks on a button. The click event, bubbles up, goes to the global listener. And then the global listener says, oh, okay, I got a click event. Let's see if I have to do anything. I don't know. And so it goes back where you clicked on it, onto the button, and says, hey, do you have an attribute which is on click? And if there is an attribute on click, that the value of that attribute will contain a URL to the symbol which I have to download. Now, again, there's a service worker, we'll prefetch it so that we know already that this piece of code is inside of the cache, right? So there's no delay whatsoever. So it says, okay, give me this piece of code, and it can go and then execute the behavior of the counter. Now, this is where the second problem comes in. Yes, you could do that. The problem is that the counter presumably wants to increment some state. So how does it know what state there is, right? So when we ran on a server, we knew that the button had a listener. That's why we put the special attribute over there. And we also knew that the system had a state, which is, the count, which happens to be 1, 2, 3, let's say. And so we serialize all of this information into the HTML. So there's like a special JSON section in the HTML that basically says like, oh yeah, there's this state called, that contains number 1, 2, 3, 4, 1, 2, 3. And also, by the way, that state is tied to a specific location in a DOM. So if you update the state, this particular text node in a DOM has to update, right? So all of that is kind of serialized, packaged up inside of it. So when you wake up, when you download the function and you're ready to call it, you can't just call it. You have to do basically the resumability step. And the resumability step is you read the JSON, you parse it, and based on that JSON, you kind of recover the state of the system, right? And that state of the system is what the function needs to be able to increment. So the function says, counter.value plus plus. And so the question is, well, where does the counter come from? And the answer is, well, the counter comes from this JSON that was recovered, right? And so this counter basically says, oh, your current value is 1, 2, 3. So when you do plus plus on it, now it becomes 1, 2, 4. And because this counter is a signal, and it also knows that it's connected to this DOM element, it knows that it has to go and update the DOM element. So now your count immediately updates, right? But notice what didn't download. We didn't download my app, and we didn't download the counter component either, right? So if you would put console.log render my app and then console.log render my counter inside of the components, you're going to see those logs on a server. In all cases, right? You have to see it because the application renders. But in the hydration world, you will also see those console logs on the client. You will see, render my app and render counter. In the resumability case, you are not going to see them on the client at all. There's no reason to download and execute my app So that one doesn't get downloaded or executed. And there's no reason to execute a counter either, because the system serialized the fact that if you increment the state of this variable, which is 1, 2, 3, it will also go and update the DOM associated with it. And so now you don't even have to download the counter. And so because you don't have to execute any of these pieces, the system knows not to even bundle them. So they're not even in the bundle. So really the only piece of code that you have to download is the piece of code associated with the button, which is just a counter.value++, right? And so you can see how this is super performant, because, we described a simple counter, but imagine you have, thousands of buttons or behaviors on the page, scroll events and mouse overs and clicks and drags or whatever. And most of the associated components just never download because, well, they're not needed. And so this is where kind of the power of resumability comes from, is A, they're not needed, they're not downloaded, but B, like, we don't even have to execute them, right? Like, in order to start executing the application, when you clicked on a button, you directly went into the button code. You didn't like execute all the stuff around it, which eventually got you the button and then executed the button. You literally started at the button. And so resumability has this weird property that it takes an application that has a single entry point and it transforms it into this application where it has many, many, many entry points. And it's that ability of having many entry points that then gives the tree shaker freedom to be like, oh, but you don't need this, and you don't need this, and you don't need this, right? Because inside of your closure for the on-click, there is no reference to the counter component. There is no reference to my component, right? And because there's no references, the tree shaker looks at it and says like, well, you don't need that. I'm just not even going to bundle it. And so that's kind of the magic.
Yeah, it feels kind of like the truth, like that, thinking about the button first, like that's the only way they can interact. So kick it off from there. It's like, could this have been done like 5 or 10 years ago? Like, could parts of this be built into like HTML or like, could this even be used outside of the browser? Like,
so it kind of was.
Operating system.
It kind of was. It kind of was. So first of all, there is an attribute called onClick, which you can put in HTML, right?
Yeah.
The problem with that attribute is that, first of all, you have to put JavaScript in there, which is not kind of nice, right? But the other problem is when the JavaScript starts running, it has, it doesn't know what the state is, right? The problem isn't executing the JavaScript. The problem is that we need to somehow recover the state of the system, right? Because sure, if you have a simple button that does alert hello world, yeah, that one has no dependencies. That's an easy problem to solve, right? But your button presumably refers to and mutates the state of the system. And so you need to recover the state of the system somehow. And the way most frameworks recover the state of the system is by re-executing the whole application. And that's, inefficient, as we discussed. And so resumability's point is like, how about we just snapshot the state of the system on a server and then move it or serialize it in a JSON format, right? Move it with the HTML to the client. And then when the client is ready to interact, we will recover that state of the system so that when the function runs, it doesn't need to like rebuild it, like it's just there.
So, and sorry, I was going to say, I tried putting a date into the store, like into the state. I'm like, I'll see if I break the serializer, but it still worked. So how does the JSON, like, because JSON has its limitations, right? So like, what can you do? And
So we can serialize, everything JSON can serialize. So that's obvious. But we can do a whole bunch of things that JSON cannot do. So amusingly enough, there is no way to serialize undefined in JSON. So we can do that. But also JSON doesn't know how to do circular references. We can do that. JSON obviously doesn't know how to do things like date, map, set. We can do that as well. We even can serialize promises. But the big thing, the mind-blowing thing, the thing that makes this whole thing possible is that we know how to serialize closures, right? Serializing JavaScript is easy because, well, that's really just a URL to a module that you have to download and execute, right? But serializing closure is more complicated because it's the function that I have to run, but that function needs internal state. right? Yeah, it's just a counter which increments the state. That's easy. The problem is, what exactly is the value of the current state that you're about to increment? That's the hard part, right? Like, how do I recover that information? And so the serialization of the state is really about that, so that when you recover the state, you inside of it have all of the information about all the pieces, but also about other functions, like other closures.
Okay, I have two questions about that.
You go, Mike. You go first, Mike. I got a couple as well.
First is, how do you even do that? How do you serialize the closure? How does that work?
Okay, so this kind of comes into kind of the magic of it. Okay, so as I said, it's relatively easy to serialize functions. So first of all, when I say serialized functions, people typically mean like, oh, we do toString and then eval it. No. There's so many problems with that approach. You can't do that, right? So instead, what we serialize is a URL to where we can download the function, right? So if you have, if you say like, oh, I refer to this component, like really component is just a function, right? Then you really have a reference to a piece of code that needs to download. And that really boils down to two parts, which is you need to have the module, right? The bundle, the URL, which you're downloading, which basically goes into dynamic import. And then once you get the module downloaded and executed, right, you want to know the symbol name that you want, because typically you can put multiple things inside of a single module. And so you need to know the symbol name as well. So if you know the URL of the bundle and the symbol name, then you fundamentally can lazy or you can serialize any function you want, right? But notice I said the word function. Functions do not contain state. What we want to serialize is closures. So you need a third piece of information. And a third piece of information is what state needs to be recovered, right? So we call this URL QRL because we're trying to be cute. But QRL is basically three things, right? You have the URL to the bundle, the symbol to download, and an array of things that have to be recovered from the state and given to this closure so that it can close over them and run. Now, the next part is closures lexically just kind of magically pull in variables into them. And so you can't have that because you can really only have functions. And so you need to rewrite your closure in the form of a function so that you can insert these extra variables that you close over into them. And so all of this basically would mean that you would have a horrible DX. Like, there is no way in the world that anybody would write this and be like, oh yeah, I love Qwik. This is great. Like, it's making me do all this extra stuff, right? And so you want to basically write the code that we've always written. You don't want to change your behavior. And so for that, we have a special syntax inside of Qwik, and that is a $, right? So when people look at Qwik, they're like, oh, I see $signs. I hate it. It reminds me of jQuery or something like that. I'm like, I get it, but there's a problem we're solving here, right? And so this problem requires, a solution. And so a solution we came up with is we need a way for you to tell us which functions we need to do this magic to, right? So that, and the magic basically is take the closure that's following the $sign, move it into a separate file, give it a top-level exported name, and of course you don't want to name things, so we have to come up with a name for you, and then rewrite the closure in the form of a function such that it looks like it is closing over the certain variables, right? And so all of that is done by the $sign. And the reason why the $sign is important is because it not only tells the system what to do, but it also tells the developer, by the way, some magic is happening over here, and you might be surprised that certain things don't work the way you think that they work. Namely, that the things you close over have to be, one, constants, right? And two, they have to be serializable. So if you have, a let foo and then you close over the foo, you would then expect that if you change the foo, that the closure would be reflected inside of it, right? That doesn't work in this particular case. So that's why we say, no, you cannot have let, you have to have const. You're not allowed to change the things that you're capturing, right? Now, inside of it, the foo object could be an object and it has a property called value and you're free to change the value, but you can't change the top level thing that you're capturing, right? So that's one. And the second part is whatever you're capturing has to be serializable. So if you're trying to close over a stream, sorry, that one's not going to work, right? If you're trying to close over a complicated class, sorry, that's not going to work either, right? So you kind of, the dollar sign is kind of it tells the system what to do, but it also tells the developer, like, by the way, special rules apply over here, so you have to follow them, right? And it turns out in practice,
do you get a
yeah, you get
compiler
nice.
error?
You get nice compiler error. Then there's linter that kind of helps you along, etc. So when you do the wrong thing, the system tells you in a very nice way that, like, hey, by the way, what you're trying to do is you serialize something that doesn't work. So please don't do that. Or it will tell you, like, oh, it's not, you're trying to capture a variable that's let instead of a const. Change the thing to it. So we tell you all of this stuff.
So I was wondering. I guess this question has two parts, but does Qwik or will Qwik give developers the ability to define their own custom serializers? And a while back, you suggested that Ben Lesh maybe write a serializer for observables. Do you know if anything happened with that?
Yeah. So we can talk about that.
Okay.
So first of all, custom serializers. Yes, in theory we can do it. We are extremely hesitant because when you click on a button, it is at that point when we deserialize the state, right? And because it's at that point the state deserialized, we have to ensure that the deserialization process is fast. We really need to do it in few to maybe tens of milliseconds, right? We cannot do it over hundreds of milliseconds, because then clicking on that button is going to be annoying. Now, it's true that deserialization really only happens on a first interaction. Subsequent interactions don't have this penalty because you already deserialized and you're ready to go. But nevertheless, we want to make sure that the first interaction is super fast, right? And so because of that, we really want to take the deserialization process to be somewhere in the range of 10, maximum 50 milliseconds, right? And if you have a custom serializer, this is where the problem starts, because as you start deserializing the system, you don't know whether the serializer is needed or not. And then halfway through, you come across like a custom serializer, and now you're like, ooh, I need to download, special code to deserialize this thing. And it creates kind of a performance bottlenecks. So as of right now, we're kind of kicking this can down the road and basically saying, you know what? We'll solve it maybe some later point in time. So we're not saying that we don't want this. We understand the value of this, but it's a tricky proposition, and so let's be sure about what we're about to do, right? So let's not let the Pandora, let's not open the Pandora box just yet.
That makes sense.
I was thinking from a business perspective or whatever, Apple with the apps, or they only allow quality apps sometimes.
Yeah.
If you guys were kind of like that and only allow fast stuff, so if anyone has a button that takes more than 5 milliseconds, you just break the app and nah. So then anything with Qwik will always be fast. But I got a feature request. Is you said undefined can't serialize. A lot of people use null and undefined. It's 3 different values based on if it exists or not in the database and things like that. In Rust, you have the result enum or the optional enum. So it would be awesome if there's something like that in JavaScript, or if Qwik could
you can serialize undefined with us. I'm saying JSON can't do it.
Okay.
So we extended the JSON so that we could do all of these things. So you don't have to think about any of this stuff. Undefined will work exactly how you expected. My only point was that JSON doesn't know how to do it. Of course, we added a whole bunch of things into the serialization system so that all the basic things that you can think of in terms of serialization and deserialization just happen. So one of the things we actually know how to do is actually errors. If you throw an error, we actually know how to serialize it so that you can get it on the other side in there. So the second question was actually about RxJS. And the hard part is that, okay, let me back up a second. Remember we had a counter example? In a counter example, if I increment, the counter is really signal, which if you think about it, signal is kind of like behavior subject, right? It's a special subset of the general observable world, and with a whole bunch of limitations, but it's just essentially behavior subject, right? And so when RX people come in, they're like, oh, you just invented behavioral subject. Like, I already have this. Like, why is this exciting, right? And it's exciting for a couple of reasons. First of all, signals are super tightly integrated with the framework. And I'll explain why in a second, why it's important, right? And the second thing is, signals do not have a subscribe or unsubscribe method, which means you don't need to do anything to get the subscription. And more importantly, you cannot leak memory with it. Something that is very possible in observable systems because you just forget to call unsubscribe. And sure, a framework can help you by async pipe and all that stuff, but there are so many ways where you can shoot yourself in the foot with this, okay? So one way to look at it is that signals are like, toy compared to RxJS. And the other way to look at it is like, well, it's just the thing that we need and nothing else. And so it's simple. Now, the other problem with RxJS, and not a problem with RxJS, but like the combination with kind of a system is that because you call the subscribe method, the RxJS internally creates essentially the graph of all the stuff, what goes where. And this graph is heavily dependent on a function, which is the callback. And herein comes the problem. How in the world do you serialize this graph with all these functions, right? If you remove all these subscriptions from the graph, it's not interesting. Nothing can happen, right? And so what you need is a way to kind of just continue execution just instantly. So now imagine if you have this counterexample, and the counterexample would be using RxJS, and you click on a button, then what you would have to execute is like, well, let's make an observable subject, and then let's call subscribe on it, and let's store the subscription in some array so we can clean up later. And then, let's do all of this work. And it's just like, no, you're missing the point. This is supposed to be fast and instantaneous, right? Which means no execution of code, just deserialize the state and move on. So the thing about signals in Qwik is that they know how to represent themselves without any closures, right? They can fully describe the world in a way that there's no closures. And so if you want to serialize them, it's just JSON to stringify, right? And if you want to deserialize the state, it's just JSON.parse. I mean, I explained that there's certain trickery we can do to kind of make it more complicated. Have these states interesting. But fundamentally, the signals can recover all the information in this particular way. And because there is no subscribe and unsubscribe methods, you don't have to serialize them. And so that's kind of the big thing why it's really not likely that RxJS in its current form can be serialized into the state, because at a minimum, it would mean that deserialization would have to require executing a whole bunch of code to rebuild this graph. But more importantly, this graph requires these subscription methods, and these subscription methods would have to be synchronously available. And these subscription methods are or functions really close over many things. And now you have the same problem, like, well, how do I get the values that these things close over from, and so on and so forth, right? So it is unlikely that in its current form, RxJS can be serialized.
Yeah. I tried really hard.
But I understand that RxJS is a lot more powerful than signals. Like, I get that. But signals can do 95% of the things, without really relying on RxJS. So I would rephrase the problem slightly differently, which is, for the most part, do everything with signals because they are so much better integrated, they're faster, they do all of these particular things, and leave the RxJS for the super complicated things that you cannot do using signals, right? And so if you look at it from that point of view, then things kind of work, and there are certain things that signals are great for, which is, observables are great for, which is values over time, right?
Yeah.
And so if you think about it, a behavior subject is not even the thing that Rx shines at. It's like this workaround so that you can read the current value, right? Like, leave that to signals. They do a much better job of that. Instead, use RxJS for these stream events. Like, where do the stream events comes from? Well, probably a socket or a HTTP or a listener or something like that. And those things cannot be serialized anyways, right? So those things you will have to rebuild on your client anyways. And so as you're rebuilding your pipeline that talks to your stream of data of stock quotes or whatever, that is the place where you can insert RxJS.
Yeah.
That was one thing I was kind of wondering if, like, say you use like set interval or something on the server, like how does it know when to stop the server and go to the client? And then also when your initialization code on the client, like say you want to run some animations or like have some other things happening, like how does that work? Yeah.
So obviously, if you set an interval on a server, then you're going to have an interval on a server, which is not what you want.
Yeah.
So don't do that. Don't set interval on a server, because that is probably not what you want. So we have a special hook we call useVisibleTask. There's no good name for it. So there's historical reasons why it's called this way. We can kind of discuss it. But what the useVisibleTask basically says is like, look, do this work, but not until the component is visible. And on a server, the component, it really isn't visible, right? Like it's not the thing, like visible from the point of view of the user. And so that is a place where you would put things such as setting up intervals or setting up socket connections or what have you. And as the name implies, it doesn't run until it's visible. So if it's below the fold, it doesn't even execute, right? Yeah. So if you want something that is below the fold and executes anyways, there's a special flag you can pass in to visible where you define what does visibility mean, right? Because the default visibility is kind of a human seeing it in a viewport, but a different kind of visibility could be like, well, actually it's rendered in a tree. That's a different way of defining visibility, right? And so you can basically say like, oh yeah, when it's rendered in a tree, which means immediately when it starts up, right?
In the past, I used like optional providers. So like I had Redis and like I could have that on the server, and on the client when the component ran, it didn't have Redis or something like that. And all these crazy things like, is it mobile or not? And things. But I guess, does Qwik have something kind of like providers in Angular?
So dependency injection. We went back and forth on this many times. I love dependency injection. I think it's great. And I think all Angular folks love it as well. On the end of the day, we decided for simplicity. And so we decided to kind of skip it for now. It also kind of complicates the serialization story, because dependency injection is all about creating things like services, etc., and those things are fundamentally not really serializable, right? Like a service that talks to your stream, like yes, but it doesn't really serialize into the system, right? So I think for now we kind of opted for simplicity. The door is still open. Maybe in the future we will add it. But I think many things can just kind of be built with it, without it. The only other thing is that in the React world there is this thing called context that you can pass in, and that kind of serves a similar function as a DI. So for those use cases where you need to pass things between parent and child components, which is solved with DI in Angular, you can use a context. So it's not kind of as nice as powerful as DI. But it removes the sharp edges that don't serialize. And so it kind of simplifies things for us. So for now, it's just not there.
Yeah.
And if you talk to the React world or Vue or Svelte world, they don't have dependency injection and they don't miss it that much. So it's not like it's impossible to build certain apps. It's just a different way of doing it.
Yeah, it's like a mixture of context and like custom hooks where you have like a shared map underneath that you can like access from multiple components.
I worked at Meta for a bit, and I did a little bit of React. I'm not that good at React, but yeah, I could see like context. Like it was a pretty big tree, like like going off the right of my screen. I need like a wider screen, but yeah. Have you seen like what they do with like GraphQL and like fragments, like for like loading all the code at once? Because I guess this is one problem I kind of have in Angular sometimes, where like I might have a tab and I want to load some details to show the label on the tab, and then within the content area I want to load the same details. So it's like I just do 2 requests to the server out of the same request, even though it's the same route, like loading pretty much at exactly the same time. But it's like seems kind of hard to solve that. Yeah.
So we have this thing called route loaders, also route actions. We can talk about it later. Route loaders is basically our recommended way of loading data, and it is done in a way where, fundamentally what it does is it puts all of the loading code in the front. So at the moment the request comes in, you execute all the loaders, and while the loaders are fetching your data, you start streaming the response, and then when the response comes across something that requires the loader, then it kind of blocks until the loader shows up, and then it continues running, right? So you want to parallelize and you want to kick off the data fetching as soon as possible, and then in parallel, you want to start rendering. So we have this pattern called loaders. This is a common pattern. It's available in other frameworks. Because of the $, we think that our DX is really, really nice because you can directly refer to the loaders and don't accidentally include them in the client bundle, which I think is a nice property. And loaders work both on a server and they basically create a proxy for you on a client. So our answer to it is loaders. And you could still use the loaders in the client and kind of update the data from there as well.
And I also saw in the tutorial there's like the resource which has like loading states or error state and things like that, which kind of reminded me of suspense list. So it looks like you guys have got some pretty nice ergonomics with those kinds of things, which is cool. I was like wondering why Angular doesn't have that in the standard library, but
resource is kind of a lower level thing where you just want to run code and you want to manage it all yourself, right? So it's a lower level primitive. Yes, and it has a really nice set of DX, but it's not the default thing we recommend because the default thing is you want to really move the loading as early to the HTTP request as possible, and so that's what the route loader does. But resource is this generic thing which can do anything.
So speaking of routing, sort of, does Qwik have a client-side router?
Yes and no. So Qwik is a directory-based route, so you kind of lay out your routes based on the file layouts, right? Mm-hmm. And normally when you have a href, that of course is a round trip to the server, but because Qwik is so good at starting up really fast, this actually works really good. But let's say you want to do a client-side navigation, right? So what you do is you change the A into link with a capital L. So now it's a component called link. And this link component basically will do the navigation for you, but on the client side without doing a round trip to the server. And so the link component then obviously has to download the route information so that it can do the navigation, and basically just runs everything on the client. The weird thing about Qwik, once you kind of use it for a while and wrap your head around, is something we call the unified execution model. And what we mean by that is that normally if you have a framework and let's say you have a component and a component has a life cycle, like on init, render, and on destroy, right? So what happens is you run it on a server, and those life cycles actually, on init, render, and on destroy will happen on the server. Then you get HTML, you send the HTML over the wire, and then on the client you do the hydration, and the component will again execute on init, render, and destroy, right? And so you really are doing it twice on both things. The two things are independent. The unique thing about Qwik when you have a unified execution model is no, the component started executing on a server, so server gets the on init, and a server gets the render, right? Then the component lives on the client, and at some point you navigate to a different page and it gets destroyed, and so the destroy happens on the client. And so if you think about it, there was only one life cycle, right? It ran init, render, destroy. That order is the same. It's just that the first two ran on a server and the last one ran on the client. So when you think about the lifecycle of components, you don't think of them on the client. You think about both client and the server, the whole thing. It's very unified. And we also have other methods, for example, server $, which can take any function and pin it to the server. So even though you are, if you're running on a server and calling a server function, that's not really that interesting. But you start on the server, the code moves to the client, and now you call a function that is wrapped in server $. That means it's pinned on a server, and the framework will just teleport you back to the server, execute that function, and then teleport the answers back to you so that you can continue running. So you can make that call. And once you can do that, you can also do worker $, right? And so you can do the same thing and move the code over to the worker. But you don't have to think about like, well, I need to create a data point. I need to serialize the data, deserialize the data. You don't have to think about any of that stuff. You just say, well, I want to do this, and off you go. It's happening.
I think for me to understand this, maybe it'd help. Like, basically, last week I deployed an app to Google Cloud Run on the back end and Firebase hosting for the front end. So it's like Angular single page app and like a Node.js backend. So I basically built it with Docker, sent a Docker container to Cloud Run. So I'm kind of wondering with Qwik, like how you deploy it. Like I guess you have a node modules and like would some of the stuff be in a CDN and stuff like that?
It's very similar to what you would do in any other application, right? You run a build. So what's unique about Qwik, and worth kind of pointing out, is that most frameworks really have no opinion about bundling. They have opinion in the sense that like sometimes they come, like Angular comes with a CLI where a particular bundler is pre-configured, so you don't have to think about it, right? But the framework itself doesn't care. It just cares that the code somehow gets to the client, right? This is not the case for Qwik. Qwik takes very active information about the bundler because, when Qwik runs on a server and you create a button and the button has a click handler, the Qwik has to serialize on :click, and now what's the URL to the bundle? Which bundle is this thing even in? Like it has to know that this click listener ended up in that bundle. And so the bundler information is something that has to get fed back to the runtime so that the Qwik can then generate the correct bundle and correct symbol name, because again, like it doesn't know where these things are, so it needs to know where the symbol name gets generated inside of the HTML, right? And similarly, like when you're running things like server $, we never send the, serialization of code is really just a bundle. So the thing you're sending across is not the code that you want to run. You're sending a pointer, right? You're sending this bundle contains this function, and I want you to execute this function on a server with these set of closed over parameters, right? And then when the function completes, it sends back a response saying like this function returned this set of things that are serialized into the state. And so the runtime system needs to have an intimate knowledge of the bundling system, right? So the two are kind of connected. So when the bundling system runs and produces all these bundles for you, we created a file called manifest, and the manifest is fed back into the runtime. So when the runtime is executing, it knows like, oh, this thing ended up in this location and this thing ended up here, and this is the URL for this bundle and so on and so forth, right? This is unheard of in any other framework. Like it's just not how other frameworks work. Like they just don't care about how the code gets anywhere. But like the moment you have these this kind of moving things around, it actually does matter, and the thing has to have. But I was answering a different question and I got sidetracked. What was I answering?
No, yeah, that was kind of it. The other thing I was doing last week was I had like my environments file with Angular, and then on my backend I had an M file, and just getting the right URLs for like development and production and things like that, so the right things talk to the right things and stuff like that. But and also I had some Rust dependencies which I had to build for Linux, even though I'm not running Linux. And I heard does Qwik use Rust? I saw there's some .node files in the source directory. So
yeah. So
I'd be keen to talk about that if this time as well. Yeah.
Yeah. Let's talk about that. So this $, right? This magic, you what you want as a developer, like if you're writing a simple application, I would like to put my whole application in a single file, right? I would like to put it in a single file, and I really don't want to think about exporting or coming up with names or anything. I just want to write it, right? And so you just write it, and you put these $signs everywhere. And it's not like you can forget to put the $sign because it's part of the API name. So, it's component $. It's not like you can say component because the TypeScript's going to scream at you and be like, what's component? I don't know what this function you're talking about is, right? There's only one function called component $, so you have to put it in there. And so you write it with these component $signs. And now you have to transform it into these multiple files with bundles, etc. And we want to make sure that this step is fast. And so that runs in Rust. So Rust is the code that does the transformation. So we have a special NPM package where we have Rust for every single platform. So Windows, Linux, whatever you have. And one of them is also WASM. so that, if we can always fall back to Wasm if the other stuff doesn't work. But that's something that's like done automatically, and it's integrated into Vite. So Vite has a special plugin which then invokes the bundler and does all this magic for you, so that it breaks it up. So you don't have to think about it. Yes, Rust is in here, but there should be no reason for you to even know that Rust is used underneath. When you set up a project or when you want to use everything is pre-built, pre-bundled. You download a specific NPM package. There's nothing for you to do.
So is the Rust running while you're developing, like on your local machine, or is it also running on the server?
No,
when you actually run?
It's a build step thing. So during the build step, we shred the file into lots and lots of small things, lots of small chunks, and then we serve that during the development. During a actual production build, you start with shredding all the files into pieces, but then you create bundles, and in the bundle you basically say, in this bundle I want this symbol, this symbol, this symbol, this symbol, and it gets put together. And so then you say, well, how do I know which symbols you want to put where? And the answer is, well, you run the application and you observe, you collect statistical data on what people click on in which order and whatever, and that gives you information that you can then give to the bundler and be like, hey, this is how people use the app. Can you make bundles that stuff that's related to each other ends up in the same bundle? And then the bundler does that job for you, so that it creates the right kind of set. Because if you think about it, like there's a slider, right? Like on one extreme, you can put everything in a single bundle. That's not that useful. The other extreme is you can put every single $sign in a separate bundle. That seems like a lot of waterfalls. That's not useful either. So the happy medium is somewhere in between. And then presumably you have some knobs you can turn to decide, like, this button is more likely to get clicked than this one, etc. And so you can tell this to the bundler, and it's a configuration information. So you have a full control about how many bundles and what goes where, so that when you are then prefetching the code, you prefetch them in specific order, and then you have to make and then the system makes sure that the button that is more likely to be clicked gets fetched first, right? And the button that is less likely or almost never gets clicked is the last one. And then that the code that never, ever executes on a client doesn't even download.
I guess 2 questions on that. So that Rust code, is it running with hot module reloading or whatever? So you get an instant compiler error with a closure, or is that TypeScript types?
So you get a compiler error from, so the way it works, you're inside of your editor, right? And so in your editor, the TypeScript is running and it's giving you all the errors. Also, the linters are running, and the linters tell you, like, oh, you're doing something that doesn't seem to work over here, right? So that is how TypeScript does things. Then you hit save.
Not the build step. Okay.
Yeah. So TypeScript has nothing to do with the optimizer, right? That path is independent. At some point, you hit save. And this is the point where you now send it to Vite, and Vite wakes up and says, you saved the file. Let me reserve the file to the browser, right, to do hot module reloading. And as Vite is running its plugins, one of the plugins is the optimizer, and it shreds it into pieces. And then those pieces are the pieces that you then deliver to the browser, right? And this is dev mode. So in dev mode, you're going to have bajillion small files. Right? That's the extreme, because we don't go through the bundling step of putting back things together, right? So in dev mode, you have like ridiculous number of files. In production mode, you have, few.
And then one more thing with the bundling, like I think I heard somewhere that you could have a statistical process that kind of knows which buttons the user could be more likely to click or something. So you could package things together in chunks, optimize.
Yeah, that's kind of what I was saying earlier.
How does it feed back? Yeah.
So every time the system needs a specific symbol, to download. So for example, when it comes across the click listener, right, the button that does the incrementing, it's like, I need to download the code that is attached to this button. Whenever that happens, the system also emits a custom event in a DOM. And so anybody can listen to those custom events. And those custom events basically tell you what symbols are downloading when, right? And so all you have to do is collect that, and then that becomes your basis by which you know which symbols are used and which symbols are not used, and when they are used, and which symbols always come together, and all that information. And so that is the information you need to then give it to the bundler. and then basically say, hey, bundler, I noticed by running the application that these symbols always come together. And therefore, or I want to make sure that all these symbols end up in the same bundle so you don't have to download multiple things, right? And the bundler will happily do that for you. But the interesting thing to kind of note here is that if you have an existing application, let's say in any other framework, let's say in Angular, right? And if you decide like, oh, I think I want to lazy load this component, right? That is a huge refactoring undertaking. Like you can't just like lazy load the component. It's like, oh, okay, take the component, take it to a separate file, create a dynamic import, wrap it in some kind of wrapper, then take the wrapper and put it inside an outleg or dynamic component or whatever, right? Like there's a lot of things you got to do to introduce a lazy loaded boundary, right? And therefore it is an active thing that the developer has to do. So if you decide that like something is a separate lazy loaded chunk, there's going to be work for you to do. Whereas if you decide like, actually, this lazy loaded chunk is not helping, I want to merge it back together, again, more work for you to do, right? So changing how the existing systems bundle your application is a development problem that requires moving code around. And a lot of times you'll realize that like you want to lazy load something, not so simple because complicated set of dependencies and you just can't separate things out and it becomes a huge refactoring effort, right? So moving things around in existing systems is extremely difficult. In Qwik, it's a configuration thing. Like there is, if I decide that like two symbols need to go to the same file, or I want to separate the symbols out, I don't have to do anything to the source code. No change to the source code whatsoever, right? I go to the bundler and I change the configuration information where I simply tell the bundler, this symbol needs to go with this other symbol. That's all I have to say. And wow, all of a sudden you have the response that you want, right? It's miles different from how everybody else does this.
Yeah, we adopted NX monorepos recently, and so we've got a bunch of different apps, and we're trying to figure out how to do the modularity of our libraries and things like that. And I saw there's a Qwik plugin for NX now, so you can just generate a Qwik thing, which is pretty cool. But with the libraries, you can kind of build them once for all your apps. You don't have to rebuild them. But then maybe tree shaking is harder if you have like one big barrel file or something. So with Qwik, do you imagine it being used in like monorepositories and like having some things in the library and stuff like that?
Yeah, totally. You can use it in the mono repo with NX and all that stuff. It's just that, Qwik has to kind of own the bundling process, right? I kind of explained, like, it has to break it up, it then has to put it together, and it has to then create this manifest file that's handed over to the runtime so that it can do all of this magic. But yeah, none of this stuff precludes you from using any existing third-party system. And oh, by the way, the bundler is just rollup, right? So on the end of the day, you're just invoking rollup, and so you have full control of what's going on over there if you so desire.
So, speaking of kind of the whole ecosystem, I see kind of Solid.js and Qwik as being really, really influential right now. And if I were any framework, I would be hoping to achieve the kind of performance that Solid does and the kind of like instant loading that Qwik does. And a lot of frameworks are kind of changing right now. Angular, they're doing like standalone components, and that makes it lazy loading a little easier, but it's still not even, not close at all to like the fine grained level that Qwik does. They also are adding signals, or they have, and I'm kind of wondering. So signals seem kind of important to be able to react and to be able to fine grain load and fine grain react. And also, I heard that React's compiler they looked at signals as one of the things that they might compile down to. So I'm wondering if is it realistic to think that to hope that the rest of the industry could eventually implement resumability if they are moving more towards signal reactivity under the hood?
Yeah. Wow. So many questions. Okay. So let's talk about Solid for a second. Solid is definitely the fastest runtime, meaning that once the application is run, it's running very fast. In that regard, Qwik is a close second. The reason for Solid's performance is that on the end of the day, when you change a signal, that signal is tied to DOM. Whereas if you look at any other framework, a change in the state usually means rerun a component. And now we can argue whether the component rerunning also reruns child components and the pruning of the tree and all this other, but fundamentally, every other framework basically ties reactivity to component rerun. And in Angular, it's kind of the extreme, which is like just rerun all the components in the tree, right? Yeah. React is a close second in terms of the extreme, where it just says like rerun any component at the location of the state change and below me, right? Whereas Solid is just like, no. This state is tied to this DOM update. So if you change the state, bam, I just go and update the DOM, right? Qwik is a very close second because usually we act the way Solid acts. In some cases, we do a component update, but for the most cases, we actually do Solid. But the thing that Qwik is untouchable on is startup performance, right? And the reason for that is because the amount of JavaScript to run on initial boot is essentially this 1 kilobyte quick loader, which executes in 10 milliseconds or so on a mobile device, and you're done, right? No other execution needs to happen. And that's just essentially impossible to beat. Like, how are you going to be faster than 1 kilobyte and 10 milliseconds? What, you're going to have half a kilobyte and 5 milliseconds? Like, even so, like there's no room to kind of go faster, right? Like at that point, you're kind of at the limit. And so the amazing part of Qwik is that we can do that, and then we can resume the app essentially instantly when you do a click. Because again, we explained that the deserialization of the state is something that usually happens in like between 10 to 50 milliseconds, right? So the additional cost on click to kind of wake the app up is essentially nothing. So then question becomes like, well, can other frameworks get there? Well, before we go there, like let's talk about signals a little more. Why are signals required? So imagine that we would have resumability property, right? So that we can resume the app and it would be just like Qwik in terms of the speed. But then imagine that we would work like Angular or React, where we would just re-render all the components. Notice what would happen on a first interaction. You interact, you change the state, guess what? You have to rerun all these components. And the real problem isn't the rerunning the components, it's that these components have to download and execute, right? And this is what would kill you. So fine-grained reactivity is essentially a guard against it. And the thing is not that the reason we like fine-grained reactivity is not necessarily because it's fast, which it is, but because it allows you to prune huge amounts of code that don't need to execute, right? So the fine-grained reactivity in signals is all about not executing code, right? And that's the trick that enables all of this stuff. Now the question then becomes is like, well, can other frameworks do this? So in theory, yes. Like nothing prevents anybody to look at how Qwik does it. I've talked about it in many blog posts, etc. None of this stuff is secret. The hard part is that, what I like to say is that the developer has to be in on it. You can't just introduce resumability and pretend you have the same exact semantic meaning to everything and have the developer be completely blissfully unaware, right? The developer is in on it because the developer is forced to put the dollar signs, and these dollar signs have special meaning. Like you cannot have a let at this location. You cannot have a thing that is not serializable at this location, right? There are constraints to what you can and cannot do at these places. Now, it turns out that these constraints are done such that vast majority of people don't even notice them because like, well, what do you usually put in the state? Well, you put a value that's JSON serializable, right? So not a surprise there. And so usually it's not like it's too big of a constraint, but it's enough of a constraint where you can't just expect to take any existing code that is unaware of this and expect it to run. There will always be some weird like corner case where like, you're trying to serialize something that we can't do. So sorry, you can't do that, right? So the hard part about resumability is that it enforces serialization. And the hard part about serialization is that the developer has to be in on it, which means that if you want to add resumability to existing framework, you have to make sure the developer is in on it, which means all of the existing code that the developer has written all of a sudden will not work.
Yeah. So even if the frameworks support it, there's like this chasm between how the code is currently written because there wasn't like the
Right.
the
And
tools.
so the real problem
way.
is that you essentially create a brand new framework that is incompatible with your existing ecosystem. Okay?
Yeah.
So now imagine existing frameworks coming out and be like, we added resumability, but if you want to move it, use it, then none of the existing libraries will work.
Right.
That is a tall order. And so I don't think any existing framework will do this jump. I think it's a jump a little too far that most framework maintainers will be unwilling to make because the sacrifice is just so big.
I really like those Angular schematics, but maybe they're not quite strong enough for that.
Yeah, it's a lot of work. I think maybe gradually, but then it'd be like several years, right?
But even gradually, like part of like a gradual migration implies that you know exactly where you're going and you've broken these things up. And this is not necessarily the case. Like it's hard to know what the path to resumability is until you implement resumability, and then you're like, now that I have it, I know the steps that are necessary to get here. And so again, like it comes down to like, will the maintainers of existing frameworks will be willing to pay that price? And it's a pretty steep price, and I'm predicting that the answer is no.
Yeah. But as a user, I want like every website right now to be using Qwik, like I'm so sick of just waiting like all day, every website I go to. So like I want it to happen. I want Qwik.
So I have two stories for you. One is when I do a lot of traveling, and when I travel, I have T-Mobile, and T-Mobile has this thing where they give you internet when you travel for free, but a super slow version of it. And then you can pay to have a fast one, right? And because I go to a lot of conferences, basically I sit in the cab and I have a slow internet, and then I get to a hotel, I have a fast internet, right? Because I'm a Wi-Fi. And then I am at the airport and that's fast internet. And then I'm at the conference and that's a fast Wi-Fi. So really, a lot of times I just don't bother paying for this fast internet because like, do I really need fast internet for the cab ride from the airport? That's just not worth it, seems like. And so a lot of times I don't. And then using the web is essentially impossible. Like you go to pages and they excruciating long time. But the nice thing is if you visit a page that is quick, it still works. Because the amount of code and JavaScript that has to download and execute is orders of magnitude less. And even with slow internet, it works beautifully. The second story I have for you is there's a company in Belgium called Rosa. And Rosa decided that they wanted to adopt Qwik. What Rosa does is they do scheduling of patients and doctors. And one of the big thing for them is that this thing has to work super fast and on crappy networks, because if you're somewhere in the village somewhere and you barely have 3G, you still need to be able to do this. And so they always tell the story where like they go to this hospital in the middle of nowhere, they can't get on the Wi-Fi because it's a hospital, everything's locked down, and so all they have is a hotspot, and this hotspot is in a building that's concrete, and so like all this hotspot can get is this crappy 3G, and so they're demoing the website on this crappy 3G, and it works beautifully, and everybody's just stunned because it's actually faster than what they're used to in terms of interactivity. And so immediately the hospital was like, yep, you're bought because it's the only thing that works here. So like sold.
Yeah.
Like you work, you checked off the box.
Yeah. Yeah. That's awesome.
We have kind of the opposite problem, but kind of similar. It's like some of our factories, they have to work even if the internet's not going. They have to keep making stuff. So we have like a desktop app with like Tori, so we can like download more code than Qwik, obviously. But then at the same time,
nice.
they have so many
you can still use
sensors,
Qwik and download the code.
Yeah, yeah. But yeah,
you can download the code. Sorry, I
Yeah,
keep
I want to
stepping at each other.
Yeah, we have like a sidecar running Node.js. We could be running Qwik. Yeah, I'm keen to talk about like what's next from V1 and like ecosystems and the future vision and stuff. But also, I guess part of our thing, we have like a visual editor as well, which you build up a reactivity graph and stuff, and we serialize the graph just in SQLite. So you have like database tables for nodes and edges and relationships and stuff. Whereas with you guys, you serialize into the HTML the actual component structure, but also the relationships between the stores and the templates, or like when something triggers, like which components need to re-render and things. So like,
That's right.
is that serialization format kind of like something other people could build upon, like an ecosystem? Like, do you think people will reinvent the wheel and like duplicate what you guys have done, or can people kind of use Qwik, parts of Qwik and stuff like?
It's not meant to be reusable. Nothing stops you from reusing it. I don't think anything that's in a serializer is really that complicated. It's a pretty straightforward thing. So you can probably write your own, which you have your own constraints on. As of right now, we don't really have like a standard for the serialization, so we're not publishing it. It's like an internal implementation detail, and this is intentional because as we're releasing new versions, we keep improving it and making it smaller and faster. So, for example, one thing that we've done recently is, when you have HTML, inside of the HTML, you'll have a string, right? The widget A, right? And then you have to serialize the state of the system, and the state of the system will probably also include the string called widget A. So now you've serialized that widget A twice, right? Once in the form of HTML and once in the form of the JSON. And so the recent improvement we've done is that the JSON now just has a pointer to the DOM and says, the string that goes over here is the same string as it's in the DOM over there. And so you don't send the same string twice.
Cool.
Right? So we can do improvements like that. And so these are all improvements to kind of shrink the size of this deserialization content.
Yeah, I saw like I got an email last week about Parquet files or something like that, how all the different ways they encode efficiently and serialize and deserialize. I guess you could have some kind of really simple compatibility layer where it's like, this is the graph and we can kind of, from this, we can generate that and then people can build with that and we'll try to keep that working or something.
Yeah, but at the end of the day, serialization is not something you have to worry about because you don't touch the serializer or the deserializer, right? Because on a server you run and things serialize, and in the client you run and things deserialize, and it's the same version. So like we are free to change the implementation details, and it won't affect you in any way.
Yeah. And so I guess what's next? So V1 just got released. So like, congrats on that. That's awesome.
Thank you.
And it looks like it's going to be pretty stable and backwards compatible. Like you're pretty happy with what you've got. And then for enterprise applications and things, is there anything you're missing? Like, do you want to bring in an ecosystem of people building things around you, or do you want to do things the Angular way where you kind of have all the batteries included? Or kind of a balance?
No, we definitely want to have the community build things. So first of all, we are working hard on the integrations with just about everything you can think of, whether it's let me pull it up so that I can have a proper list here. Whether it's CSS library like sorry, I'm drawing a blank right now, Tailwind, or styled vanilla extract or post CSS is all built in. And I mean, we have plugins basically to built in for it. We have Auth.js, Cypress, Builder.io, image optimizations, icons, internationalizations, module forms, NX you kind of mentioned, right? Partytown, Playwright. So all of these things are kind of out of the box already integrated, and the plan is to do even more integrations. So we don't want to solve the image optimization problem. We don't want to solve the CSS problem, but we do want to integrate with the tools that kind of are solving these problems. So that's kind of the philosophy. At the end of the day, we only have 4 people working on open source, and so we want to focus on kind of growing the capabilities of the system rather than like solving the whole world.
Yeah, and how is it like building in the open? Like, I guess it's a have a lot of more benefits. Like some people are kind of scared to build in the open in case people copy them or something. But I feel like you get so much more benefit from being open source sometimes,
Yeah. So I find it amusing when people are like, oh, somebody's going to steal your idea. I'm like, I went on a stage in 2019, told the world how to do this, and
Yeah.
nobody did anything, right? Then I started building Qwik, and I go to conferences and I talk about this thing. And instead of people stealing it, they're arguing like, oh, it's just a different form of hydration. Hydration could be just as fast. Oh, we just have to do whatever, and it's not really worth the trouble, right? So like instead of stealing, like I just have people trying to convince me that this isn't worth the trouble. So yeah, I'm not worried that that's going to happen. But I think what is kind of happening right now is that people are kind of realizing, that the speed benefits are there, and it's impossible essentially to duplicate because again, you can't be faster than doing nothing, right? Like that's the ultimate limit, and Qwik is pretty close to doing nothing as you can get, and so for startup performance, Qwik is essentially impossible to beat. Or rather, the only thing that can come close are systems that also do these kinds of tricks. So the only thing that comes close is Astro. But Astro is really meant for like more static websites. They have these islands, etc. It's not meant for like full-on applications. So one of the things that Astro doesn't solve is inter-island communication, right? Sure, you can make a buy button that's an island, and you can make a shopping cart that's an island, and it will lazy hydrate, which is still slower than what Qwik does, but like it's way faster than a normal hydration system. But now you have a problem, which is, well, how does the hydration, the buy button island talk to the shopping cart island, right? And Astro's like, well, maybe in the future we'll have some API, yeah, right? And so the value of something like Qwik is that first of all, it's not even islands, so I don't want to use the word island, but like you get all these benefits out of the box. You don't have to do anything, and you can just talk to the any component in your tree just like you would talk to it in any other framework, right? You can keep your same mental model, right? You don't have to do anything different. You can just build an app the way you've always built it with all of the best practices that you're familiar with, and you get all these benefits without having to change what you're doing, right? Even with Astro, you have to change what you're doing because you're saying, well, this is an island, which basically means it's a standalone application, right? So you have to break up your app into smaller apps, and then you have to figure out, well, how do these apps talk to each other? And you have to solve a whole bunch of other problems that are just non-existent if you treat the whole thing as a single application. And even in Astro, you then have to things like, well, how do I prefetch things? How do I make sure the code is ready? And all these things. How do I serialize data on the server and the client? Like none of these things are really solved out of the box. And so here they are. But really, it's unfair to compare Astro and Qwik because they solve different things, right? Qwik solves you can use Qwik to build static sites, and you can use Qwik to build dynamic applications. But Astro is really meant for more like building blogs or presence or landing pages or things of that sort, right? So it's not the same thing. It's it's like comparing a car and a bicycle. Like it's not meant to do the same thing. So for car to claim that it's faster, better, and whatever is silly because it's a different thing.
Also, one thing I saw you mentioned, I think it was that you took asynchronicity into account from the start. But I didn't quite understand that. I thought maybe it was to do with clicking the button, or if you click two buttons at the same time or something. I'm not sure.
It's everywhere. So a basic problem is that when existing frameworks render, and I have to clarify, when I talk about rendering, I mean executing the component tree and computing what has to be written to the DOM. I don't mean actually the DOM rendering, right? So I'm talking about the framework side rendering, not the DOM rendering. So when existing frameworks render, they do it synchronously. So when you say go, right, they all render synchronously and they return synchronously, right? And because of that, you can't have any async functions. Like as you're rendering, it's not like the framework can be like, I don't have this component right now. Can you wait a second while I go fetch the component? Nope. Bad things happen. Things blow up, right? So you can't do this. But Qwik was designed from a ground up. And so if you're a React user, you're going to say like, sure you can, you have a suspense. Well, wait a minute, suspense is not the same thing, because what suspense does is it synchronously renders, and if you come across asynchronous boundary, then the rendering, the system like gives up and says, let me load the boundary, and then once it's reloaded, let me re-render from the beginning again, let me try again, the full rendering pipeline. And if I come across another one, then you give up, wait for it to resolve, and then you start from the root again and try rendering it again. So it kind of does this tries over and over until it succeeded. Qwik works differently. Qwik actually renders, and if it comes across something that's asynchronous, it stops rendering, but it has to make sure it doesn't flush it to the DOM, right? Because then you would see an intermediary state, which you don't want to see. And so it keeps the rendering in a kind of an asynchronous pipeline, and it's kind of going through it, not going back up, right? So it's not like it retries the whole thing. It just pauses, resolves it, and continues rendering where it stopped. And then once the rendering is finished, then it flushes everything in a single shot into the DOM. So to user, it looks like a transaction, whereas to the actual rendering pipelines is asynchronous. And so it's not just that, it's also like you have event listeners. They have to run asynchronously, because you might not have the event listener at this point. And even if the event listener is in the cache, which means that you're going to have it immediately, it's still an asynchronous operation. There is still a promise involved. And so the whole Qwik rendering pipeline is kind of lives and breathes promises, because it has to be anywhere. So for example, the thing you can do is you can just data bind a promise somewhere into the UI, and the Qwik is just like, yeah, no problem, there's a promise here, and so I will render it when the promise resolves. And you don't have to like try again or set up a listener or any of that stuff. Like it just does the right thing out of the box. So the whole pipeline is fully asynchronous.
Awesome, man! This is so cool.
I think it's the way the framework should have worked from the very beginning. This is how it should have been done, right? But instead we went down this path of like, oh no, we're going to do everything in a client, and so we created client-side rendering. And then we were like, yeah, but the startup is horrible, so let us pre-render things. But we didn't actually improve the startup performance. We just show you a static picture of the website while we continue being slow, right? And that's kind of where we are today, right? And so Qwik just basically says, well, how about we just rethink everything and try not to double download, double execute, double serialize. And what would that world look like?
And I kind of think you guys are getting pretty good traction. Like big e-commerce people with big websites with lots of buttons, or people with websites that need to run in places with bad internet. But now, I guess with version 1, like anyone can really use Qwik. So I'm pretty excited to see like how the ecosystem forms, and hopefully use it for some projects coming up. Yeah. Mike, how are you going? Have you got many more questions?
No, I'm good. I'm just so like I'm kind of idealistic. I don't like trade-offs. I want to win at everything. I want fast initial load. I want interactivity afterwards. So Qwik makes me really happy that you can like have something that's good for static sites and good for interactive sites, and you don't have to stress about like choosing, because like startups, you don't know the future. You have to be able to pivot. You never know if you're going to need something new. And Qwik, if you invest in it, you're not going to have to rewrite everything. So that's what I really like.
That's the plan. That's the plan. So now it's about convincing the world that this is real. I think part of the reason, part of the challenge in front of us is that we make all these crazy statements like, no JavaScript, we're super fast, great startup, right? And I think people are just like, I've heard this before, I don't believe you, right? And it's true, like we've heard this before, and it turned out not to be the case. But I do think that Qwik actually delivers, and it doesn't deliver because we are, trying harder. I think it delivers because we fundamentally sat down and said, okay, let's rethink everything, because the current mental model isn't working, right? And so our performance is not because we optimize the heck out of something, right? Our performance is because, well, we just don't do it. Right? We think we're super clever about let's just not do stuff, right? And this is where the performance is coming from. And it's hard to be faster than doing nothing.
Yeah, love that.
It's like you tried to measure the performance, but you didn't do that, so you don't know. What's your favorite Qwik joke?
Quick joke. Man, there's so many, right? Because it's so similar in terms of spelling, etc. I don't know. Do I have a quick joke?
Yeah, it's
There's a
good.
lot of like this, instances where like, haha, you said quick, haha, but it's not really a joke.
Yeah.
I have a lot of
I
dad
keep,
jokes, but
yeah, I've been thinking of a few recently. I was like, gonna make a quick joke, but didn't have time, or like, yeah, anyway. Yeah, I feel like it's kind of similar with Rust. Like you can see Rust is pretty popular on the Stack Overflow surveys, and they promise like a couple of different things which you wouldn't expect to go together, like performance and safety, or performance and ergonomics or something. And some of it can be hype train a little bit, but like some of it is, if you set some goals from the start, then you can achieve it, And like with Qwik, it kind of feels like a new paradigm where like I looked at the developer experience and it looked pretty awesome, despite having really good performance. So
yeah,
I'm really excited. Yeah.
we fought this super hard. I mean, we had a prototype early on which kind of showed all the performance promise, but the DX was horrible. And
Yeah.
then we spent a huge amount of time trying to figure out how to make DX better. And there was so many times where we're like, this is impossible, we can't do it, we're giving up, whatever. But somehow, you sleep on it and you wake up in the morning, it's like, I have a crazy idea. And so there's lots of pretty insane engineering that went into it. But the basic idea is pretty straightforward. It's not hard. It's like, just don't run stuff that you don't need to. And so let's be clever about how to figure out what doesn't need to be run, and just don't ship the stuff and don't run it. And, I have this philosophy in Qwik, which is that if you load a piece of code into the VM, then you should be running it. Like if you loaded it and didn't run it, then why did you bring it in, right? So like in in dev mode where you don't put bundles together because you do everything individually. My philosophy was like, how close can I get to the point where like the code coverage will stay at always at 100%, right? Because it's always just getting just enough to execute the next part, but nothing more.
Yeah.
Now that goes against prefetching things and putting things together, etc. So in practice you don't want to do that, but that's kind of the extreme, and then you can always back up from there.
It's like you're loading the tree of possibilities one step at a time, one button click at a time or something.
Yeah.
What would you say to like someone new to web development that's trying to decide what framework to learn? Like how many frameworks do you know? Like would you learn all of them, or?
I try to have enough knowledge for different frameworks so I can reason about the benefits and drawbacks, etc., between them. So if you're learning a new thing, there's two things you can consider. One is kind of intrinsic limitations of a technology, and then there's also the extrinsic. What I mean by extrinsic is like Qwik is a new framework, and so it won't have as much questions on Stack Overflow as one of the older frameworks like Angular or React, right? That's an extrinsic problem, right? This is not the fact that you're going to have a harder time because there's just your question hasn't been asked or answered is not a fundamental property of the technology. It's just a situational property of where it is inside of its life cycle, right? And so if you're brand new to coding, etc., you may want to consider extrinsic factors that might change. And so maybe Qwik is not the best thing to kind of look at. But if you are more seasoned and you want something that's more performant, etc., then Qwik is probably the thing to do, because intrinsically, if you look at these fundamentals, Qwik has properties that no other framework can match, right? As of right now. And so it really comes down to like, well, what do you value more? And so I think that's part of the kind of constraint that would use it. But if you subtract out the extrinsic kind of reasons, I don't think Qwik is any harder to learn than any other framework. I would say it's on par with learning like React or Solid. Fundamentally, they kind of work the same. I mean, the DX wise, they kind of work the same way. And so it's about the same kind of learning. I would say, Solid is slightly more complicated than React because you have to understand signals. So it's a bit of a thing. And Qwik is slightly more complicated than Solid because you also have to understand these dollar signs. But they're not humongous jumps, one. And two, you can actually go pretty far without really understanding signals and understanding the dollar signs. If you like stay within the rails, then you don't technically need to know how all this stuff works. And you just know that these are these rules that I have to follow. And if I don't follow them, then linter screams at me or I get a runtime error, then I fix whatever I did. You can get pretty far without even understanding these things. So I would say that mental model wise, in terms of like what concepts you have to understand to kind of get going, React or Solid or Qwik are pretty low. And I would actually say that Angular is probably pretty high because there's a lot of things you have to understand before you can kind of build something in Angular. So it's kind of a more enterprisey kind of a framework. But again, you have to weigh this against the extrinsic situation that like it's a new thing, and therefore there will be fewer people you can ask for help. Therefore, there are fewer page Stack Overflow questions. There's less documentation available out there, and so on and so forth.
Yeah. Oh, maybe we should end it there. But I just want to say thanks so much for like all your contributions to the web and stuff like Angular and Qwik. It's been amazing. Definitely used Angular a lot in my career, and looking forward to using some Qwik.
Thank you.
Yeah, Mike, you have...
Yeah, you made web development better. Like from the first time I used a framework, it was Angular JS, and just ng repeat, not having to manually manage lists. It was so nice, and just like every step, it's better and better. So
I just want the web to win, and web can only win if it's fast. So I just want the web to be fast. Really, fast and also make it easy for the developer to do the right thing. One thing we didn't talk about, I'm going to mention it briefly, is that a lot of frameworks basically have two paths: a path of like getting it working, and then the second path of like optimizing it so that it's performant. And one of the things we tried really hard in Qwik is that there is only one path. The easy path is the performant path. There is no optimization path.
That's awesome. I love that.
No prioritization or anything. Just go for the perfection. So
that's right. Do the right thing from the beginning, and then you don't have to worry about all these other things later.
Awesome. Oh yeah, and great to meet you, and look forward to seeing what happens with V1 and be following it closely. And yeah, nice to meet you.
Thank you.
Yeah, likewise. Thanks for coming on.
Anytime.
All right, I'll figure out how to end the recording. There we go.